Hello, and thank you for joining us for our water webinar, Preparing for the Wet Weather Monitoring Season. If you have any questions during the webinar, please only utilize the Q&A function within Zoom, as this function allows us to pull a report concerning your questions, and this will allow us to fully answer your question in detail at a later time. This webinar will be recorded and a video will be made available in the next few days. Today, we are very fortunate to have 3 experts concerning this topic who have a combined 91 years of experience. Our presenters today are Bob Glenn, Western U.S. Water Platform Manager, Steve McManus, and Dennis McGinnis, our Product Support Specialist. As with many of you, all 4 of us are working from home today, and Teledyne ISCO wishes you all well. To begin, I will turn it over to Bob.
Thank you very much, Sharon. Good morning, everyone, or good afternoon for our Eastern time zone dwelling friends or others internationally. Once again, welcome to today's webinar. My name is Bob Glenn, and I'm the manager of the Western U.S. Territory for Teledyne ISCO. I'll be hosting today's webinar along with Sharon. In today's webinar, we will be examining many different areas in which you and your staff can optimize the use of your time in preparation for the onset of field monitoring operations during the wet weather monitoring season. Perhaps you have some extra time due to the COVID-19 shutdown. And this is a way for us to give you some information that will help you be very efficient in your operations moving forward. As Sharon said, today's presenters are myself, Bob Glenn, and we're very fortunate to have 2 of our very best joining us to present the webinar content today. Mr. Steve McManus is our most senior product support specialist and one of the most knowledgeable people that I've ever met when it comes to understanding instrumentation and its proper use. His counterpart, Mr. Dennis McGinnis, is also one of our veteran product support technicians who understands instrumentation and the applications relevant to its use. Dennis also serves as one of our in-house experts in communications and software. So between Steve, Dennis, and myself, as Sharon had said, we bring over 90 years of experience in the water, wastewater, stormwater monitoring industry to today's webinar and content. So yes, that means we're old. It also means we have a little bit of wisdom and have seen a lot of different things. Today's goals, really first and foremost, before we embark on a discussion of planning and preparation and other steps to take as we prepare for the wet weather monitoring season, we must first define what is meant by the term wet weather monitoring season and how that applies differently depending on where we are at in the country or in the world. Secondly, we want to provide BMPs to help you optimize your operations. For those of you who are not familiar with BMPs and their use, I'll discuss this briefly. The content delivered by Steve and Dennis will focus primarily on 4 areas, and each of those 4 areas are shown in the sub-bullets shown below here: in general preparation and planning, site reconnaissance, qualification, equipment care and maintenance, and finally, the all-important data quality collection and analysis. That's why we do what we do, is to generate quality data. So first, defining our wet weather monitoring season. What do we mean when we say wet weather monitoring season? Put simply, it's a period of the calendar year in which the majority of the precipitation falls for a given geographic area. The wet weather monitoring season is typically the time of peak activity for planners, engineers, operators, field techs, managers, and others in our industry, because this is when the vast majority of the events of consequence take place. These events on the wastewater and stormwater side pertain to combined sewer overflows or sanitary sewer overflows, infiltration and inflow and collections, and CMOM work is huge, as we all know, and especially communities that are dealing with consent decrees. And then also peak flooding and property damage is a huge issue, not just because of the monetary issue related to problems, but also the PR black eye that many cities get if your system is frequently flooding and causing problems for your citizens. So to define wet weather monitoring, what are we talking about? It really depends on the geography that you're in. The Western Territory that I manage, basically everything in the United States west of the Mississippi River. And so as you can see from the maps, our first challenge is defining exactly what that wet weather monitoring season or where it occurs for any geographic area. For those of you in the Midwest, like myself and those of us at ISCO, this is in the spring and into the summer months, as you can see from the top two maps. Conversely, the US West Coast and some states in the south or eastern United States experience their wet weather seasons during the winter months in the Northern Hemisphere. So it really does vary depending on where you're at. Now, I can tell you that having worked in these markets for over 30 years, I've seen some change over the last 3 decades in terms of how we define this. Inai and stormwater runoff events were extremely rare in the Midwest back in the 90s when I was working for a municipality, POTW. And that's because all the precipitation which fell during the wintertime was in the form of snow and only became runoff once spring rains came. So flow monitoring was essentially seasonal. But now, nowadays, the way the world is, and we see many more climatic variables, which have caused an increase in anomalies, thunderstorms in January, thunder, snow, all of these kinds of things. And the bottom line is the wet weather season is dynamic and it is slowly changing over time. So we have to adapt. Finally, a little bit on BMPs before I hand it over to the other two esteemed gentlemen. Many of you have heard of BMPs and use them every day. Perhaps without even thinking about it. They're simply the best management practices that are used every day to make our jobs go smoothly. They lay out instructions or processes to optimize staff activities. In the case of instrumentation, this often pertains to detailed pre-planning for field activities, procedures, for maintenance and updating equipment, and steps to assure data quality. Having been a member of a field crew many years ago, I realized how critical this step is, because many times we would get out into the field and realize we lacked a specific piece of equipment that was necessary to complete the job. So the planning and being thorough is really critical in terms of being efficient. Given that we live in an age now where our limited resources are being spread thinner than ever, and I think that's true for not just municipalities, but many of our industrial clients and engineers as well, all organizations can benefit immensely from the use of BMPs, which will be shared in this presentation. So without further ado, I will pass the mic to my good friend, Steve McManus, and we'll get on with the rest of the presentation. Thank you again for joining us.
Thank you, Bob. I would like to extend my welcome to everybody that's attending today's presentation. I hope you find the next 45 minutes or so to be very beneficial to you in your daily life. So what I want to start talking about is the preparation for the monitoring season. And that could be spring, it could be fall, it could be winter, as Bob indicated in his prior slides. So the most opportune time to begin that preparation is at the end of the previous season's monitoring period. So when you were removing the equipment for the field after the wet weather season, that's the most convenient and opportune time to check equipment over, and if needed, take action to implement repairs if needed. So when we removed the equipment, did we check the equipment for any issues and document those issues based upon an instrument by instrument basis? Were there any physical issues observed with the equipment? Were the cases intact? Were there any cracks or sign of physical harm to the unit itself or the sensor device? Were there any signs that the case integrity was compromised because the environments these in is obviously a very wet and humid environment, and electronics and water do not mix very well? Were the connections free and clear of any contamination or corrosion that can impair the electrical performance of that system? If there were issues, were they corrected? In other words, did we either repair or maintain the unit in-house, or did we return it to the appropriate repair facility? If the equipment does have indication of issue, what level of service is required? Were there any performance issues in the field noted from that specific piece of equipment? Problems could extend beyond physical appearance of the equipment. Were there any functional issues? Was the unit performing the job of providing good, continuous, and accurate measurements? Was there any sign of drift or instability in the measurement? Was there frequent need to recalibrate and readjust level? If so, that could be reason to have some suspicion regarding that specific sensor. Was the sensor itself clean of debris or substances on or around the measurement transducer that could have impaired the measurement in the field? Consistent measurements. Please note that the measurement problems are not always an indication or the result of an equipment issue. Site conditions can impair performance as well, and more on that to follow. Did we check the desiccant, the seals? Did we check the electrical contacts? Did we check the physical condition of the sensor and the equipment? Storing the equipment with saturated desiccant will compromise seals that may have already allowed moisture to enter the case. Corroded connections, etc., will only guarantee that the impact of these issues will be magnified over time and places the equipment at great risk. It is late in the game to discover and address such issues if we are near the time to redeploy for the next season's monitoring. The time to act is now before placing the equipment into storage. Did we store the equipment in a reasonably good location where it was dry and physically safe and not at risk of being knocked off the shelf? Also, an evaluation of what worked last year would be very good to do. And this is a very holistic question and ranges from the pre-planning stages to installation practices, site maintenance, data collection, data analysis, in other words, the whole 10 yards. You want to identify what worked last year so those same practices are ingrained in this year's monitoring program. You want to repeat what worked well. Likewise, what didn't go so well last year? This is the opposite, but equally important as the same point above. What didn't go well last year and why? And what can we do to ensure that we don't repeat and have the same trouble again? For example, did we fail to have the proper tools on hand when installing equipment that delayed getting the equipment implemented and in the field? Were there locations that were more difficult to install and service due to things like traffic, access to the manhole? Were there any installation issues that could have been avoided to improve results? Did we fail to provide proper documentation to the field crew for site configuration? If we don't configure the equipment correctly and based upon what our desired needs are, we're not and should have no reason to expect to get the results we're after. Did we fail to identify our log issues up front when installing? Did some of the sites have hydraulic issues that impeded good measurements? For example, debris, submergence, etc. all of the above can impair the quality and accuracy of our data. What were the lessons from last year? In other words, if we had to do it all over again, what would we do differently? Did we make notes of what worked well and what didn't? If not, that is lesson number one for this year. Begin to keep a diary or a logged document of our monitoring program so that we can pass that knowledge on to next year. Since there are holistic things that cover the entire range, it would be good to have a section in that document that covers the general issues. In other words, the things that would apply to all monitoring locations, not just limited to site-specific concerns. It's also a worthy idea to have site-specific comments that allow for quick references, especially if those are the same locations that we're going to be targeting this year from last year. Did we have a checklist of things from last year? Was that checklist sufficient? Were there any holes in that list? The more methodical we make the process, the better results of our monitoring program will be this year. And with that, I'll turn this over to Dennis.
Good afternoon, guys. So I'm going to cover the pre-planning slides, and then I'll pass it back to Steve. And let's go ahead and switch the slide here and get started. All right. So what are the objective and needs for this year? As the saying goes, if you don't know where you're going, you'll never get there. So ensure all members of the monitoring team understand the goal and that all will be moving in the same direction. So some of the unknowns. This is the information, this is the function of communication amongst the team members and a full review of prior monitoring seasons. Have checklists developed. Simple things like, how many batteries will we need? Do we have the number of monitors, for the number of locations we'll be deploying to? Do we have adequate spares, just in case? This would be main units and sensors, communication cables, etc. Do we have adequate supply of materials for installation, cable ties, mounting bands, hardware, etc.? Are laptops in the field up to date and fully functional? Do the field crews have knowledge and of the required to install, knowledge required to install the configure the equipment? You'd be surprised the number of calls we get where individuals are handed a computer and monitoring equipment and told, go install this. They don't even know, where to even get started at. So a lot of times we get those calls from the field where we're basically installing software, showing them the ropes, etc. So things they can do in the office before they get out there definitely make field installations quicker and easier. Are the field crew vehicles supplied with communication cables? Has the safety equipment been verified to tip-top shape? Is the harnesses, air monitoring equipment, blowers, etc. Have they all been verified and working properly? Basically, we never want to assume anything before going out to the field. You want to verify it before you even leave the office. So some of the equipment to check before you go out to the deployment would be things like desiccant, physical condition of the equipment, as Steve mentioned earlier, seals, initiate connection to the equipment, make sure everything works so you don't have to do that when you're out in the field as well, having new batteries on hand. When you're in the field installing, that's really not the time to discover you have a problem. You want to have all this stuff figured out before you ever hit the field, and so that way your time is more efficiently used and not spent using troubleshooting. Checklists are really good to have before traveling to the field, are very vital here actually. Further, select appropriate sites to meet the purpose. Are the sites selected able to provide the data that you're looking for? Reconnaissance before deployment is beneficial to identify potential issues before installations, so that as needed, alternatives can be considered. Do they have good flow hydraulics that will provide quality measurement? Are there debris issues that could impair the results? Are there signs of surcharging, backflow, stagnation? Are the sites reasonably accessible? And are there safety concerns that would give reason to consider alternative locations? Is the infrastructure in good shape? Is the pipe collapsing? Rungs for hanging equipment on, are they sturdy? Brickliners degrading, etc. All these can impact the quality of accuracy of the data, not to mention the potential safety of the equipment. If they can be addressed, do so before the active installation even begins. If they can't, then select suitable alternatives for these locations. A manhole upstream or immediately downstream may be another option.
And now regarding implementation. A quality pre-planning routine that involves things like checklists, communication among the team members, so everybody's rowing in the same direction, ensures that we have a very quality program. As the old saying goes, measure twice, cut once. So when we're getting ready to head to the field to do the installation of the equipment, we should make sure when we stockpile or stocking the supplies that the field crew would need, make sure we have the proper tools we will need for the installation, screwdrivers, wire cutters, whatever. Make sure we have a supply of fresh batteries on the vehicle. Make sure we have the required mounting equipment based upon the sites that we're going to. Have some documentation that details the information for configuration. And these would include things like the site name, the pipe shape and size, the recording intervals for the data. If we're providing any alarming capabilities because we have instrumentation that has telemetry, what do we want to trigger those alarms on? All of these things should be known before that field crew arrives at the manhole to begin the installation. That's not the time to figure things out. Have a configuration plan. Beyond the differences between the pipe shape and size, try to keep other things consistent. Things like consistent storage rates. So that gives us the ability to conduct a proper comparison in our data. It's very difficult to get a proper comparison if one instrument's storing at 1 minute and another device is storing at 15 minutes. There may be applications where it would be beneficial to have a variation in that. If you have an application that's prone to very rapid and quick increases and changes in the state of flow, that may be an application where one would want to have a more rapid storage interval. If the application is more consistent and more lax in its changes very slowly over time, we could get by with a less frequent storage rate. Have a consistent and meaningful site naming scheme so that when anybody that's a member of this team that's going to be performing the analysis of this data are able to look at it and know immediately where that location is at. Avoid very lengthy site names. It just makes everyone's life more difficult. Do the observation of the installer match the notes from the reconnaissance? In other words, when they're at the site and beginning to do the installation, if there has been some notes taken on that specific site, are those conditions still the state of that location today? Were there any observable changes in the infrastructure? If we have performed a reasonably and good reconnaissance in advance of the monitoring deployment beforehand, most if not issues that could be encountered and cause problems for the installation should be known and should have been able to be addressed as needed. And this makes the installation process a very highly efficient one. But things do change. Verify and confirm the configuration on the first data retrieval site visit. Don't assume, again, if we get out to the site and we need to go through, especially on that first visit, and make sure that information such as our pipe shape, size, data logging intervals are all according to what our game plan was. Everybody can make a mistake, and so verification is very important. When on site and doing that data, especially that first data retrieval, evaluate the quality of the data right there in the field. Make sure things are accurate as far as level measurement, that there are no signs of measurement problems in the data. We're getting good, consistent information from level. Is level accurate? Is there any need to adjust or calibrate level? Is there any signs of deviations or instability in that level measurement? For the velocity measurement, if that's part of the equation, is the velocity data good and consistent throughout the data? If there are measurement capabilities that assist you in evaluating the quality of that velocity measurement, does that indicate a good quality and consistent measurement capability? If there are any indications of problems, such as debris, silt, etc., correct it now. Don't go back to the office and hand off data to the person doing the analysis, especially if you knew there was a problem in the field. The best time to identify and address an issue in the field is during that site visit data collection procedure. The worst time is after that data has been returned to the office and the analyst says, something's wrong here. That would necessitate a second trip to the field to address an issue. Worse yet, it means that from that data retrieval time to that second visit, all we have is more data that is compromised, and that wouldn't have been compromised if we'd addressed the issue at the time of that site visit. Note these issues in the log so that they are flagged and available to inform the person on the next site visit that they existed. This also allows us to discern, is there a trend with this issue? Are they due to site issues, such as a common and constant silting problem, a ragging problem, a surcharge problem? If there are consistent issues at that site, maybe we need to consider an alternative location, a downstream or upstream manhole. Continuing to try to expect good data out of a site that's proving itself to be a poor location because of site conditions is never going to get us good data. Were the issues related to equipment? If they are equipment related, swap out the suspected component and evaluate the questionable component back at the shop. Equipment issues don't go away. Swap out the source as that is the fault as soon as possible. As a side note, this is why it's a good idea to have spare units, sensors, batteries, or whatever on hand for your field crew so they can address those problems immediately when they're observed in the field.
Okay, so post-collection data analysis. Next slide. That's what you got. All right. Verify the configuration. Okay, this is just good practice to do this first before proceeding to perform more complete analysis and then discover we have a problem. So better to verify the configuration up front. If we do have issues, can we recover from these issues found? If there's an issue due to a wrong pipe size or level adjustment or periodic measurement issues due to fouling, etc., there are means to easily recover from those factors and increase and improve the bottom line accuracy of your data. If the data looks good, we can go ahead and proceed to the report generation process. But the actual end question is, did the data provide the information you were after? And if not, why not? Even good quality data can at times deviate from what the expected result was. So seek the answer as to what was behind that deviation. Remember, data always has a story to tell. Even if the data is less than perfect, don't just disregard the questionable data. See the story it has to tell. Get some value from it. So as an example, if you're performing an Inai analysis, leaky pipes, to find that the location is prone to severe silting, or unfortunately the sensor was covered in a short order after installation and failed to provide any good velocity during the event of interest, well, you can, if you do observe that the level increases substantially with each significant rate event, well, then you can deduct that that level is clearly linked to the rain event. And therefore, it is not a stretch to say that the line is suffering from Inai problem. So you did learn something about that location, even if some of the data wasn't there to help sustain that. And after that, I believe all we got are questions. So I will open this up to the attendees to ask questions, and Steve and I, and maybe even Bob, can jump in and answer any questions you got.
And I would also add that, sometimes after these, the questions pop in your head 30 minutes from now, an hour from now. You're very welcome to submit any questions to the product support team at ISCO, and we'd be more than happy to provide any of those answers that may pop up after the fact. So if something pops up today, tomorrow, next week, please, by all means, go ahead and send those questions in. There's a question here regarding a FlowLink application on the works. I'm going to take a somewhat of a guess on what the basis is of the question here, is that this is probably looking for some sort of interface where you can look up some data on your cell phone or some internet connected device to be able to view and take a look at your data. That application in some regards does exist today if one is using FlowLink Pro and has purchased and added the FlowLink Global add-on to FlowLink Pro that would allow you, with a username and login password, take a look at your data online from any internet connected device whenever you see it, the need to exist.
Okay, we got a question of who is my local ISCO representative. Basically, I think what they're trying to point out here is that we do have a representative search engine on our main website. So if you go to isco.com, in the upper right-hand corner, there is a link there you can click to find your ISCO rep or distributor by typing in your country or area code along with the type of equipment that's in question. That will then pop up the contact information for that representative.
Okay, are there any further questions? If so, please enter them now.
Sharon, we have an additional question. Customer asking, what are the potential sources for drift and need to recalibrate? What are the possible solutions and suggested tweaks that I can give my field staff so they can troubleshoot while out in the field? Steve, you want to take a stab at that one?
I'll take a stab at that one. A lot of this question is very general in nature, simply because we have different measurement technologies that could be in place. We could have an ultrasonic sensor. We could have a pressure transducer. We could have a bubbler measurement system. So the issues that could cause some deviation from the actual level can vary between those various technologies. The most common question or cause that would come behind some drift or need to calibrate is any device that uses a pressure type of measurement. Those devices have a reference line because they need to compensate for changes in atmospheric pressure. As storms come over, the barometric pressure drops. As high pressure sensors, the instrument needs to have a means to compensate for those impacts on the depth measurement. If it did not have that ability, as the water level would, as the atmospheric pressure rises and lowers, that would have an impact on the level measurement. Most of those reference lines have a desiccant cartridge that is there to keep moist air from getting into the reference line. And if that desiccant becomes saturated, it can begin to impede or restrict the free passage of air in and out of that reference line, and that in turn will begin to have impact on the level measurement. You can get sensors that have a pressure transducer that may have been fouled, that has silt or sediment built up in, that's contacting the pressure diaphragm. For bubblers, you could have a restriction begin to build in the line. Ultrasonic sensors, by their very nature, generally it's technically impossible for them to drift. So usually if you'll see some drift or some deviation on, if you're using ultrasonic level measurement, it oftentimes is the result of something happening with the mount. The position of the sensor is changed. And so as far as measures to diagnose and troubleshoot those, just to investigate all the above based upon that specific measurement technology in use. There's some questions that are coming through on the chat. So just to reiterate, please use the question and answer for those questions so that they get logged. There's a question here that talks about having an area velocity sensor in a dry pipe and exposed to sunlight. That's not a good thing. Temperature will have an impact on electronic performance. So if that sensor's in a dry pipe and it's exposed to direct sunlight, as the solar heat builds up on that sensor, it will cause and induce deviations in the level measurement. And it could give false indication of an event as a result, but yet someone's going to look at that day and date and say, it was 90 degrees, not a cloud in the sky, yet I'm showing 2 or 3 inches of water here. Well, that's because you're impacting the performance of the electronics due to the solar heat that can build up on that. And the same would be true for the ultrasonic sensors. Ultrasonic sensors, and specifically the speed of sound, is impacted by air temperature. So if we have solar heat building up on that sensor due to its exposure to direct sunlight, it's going to absorb a lot of heat and cause the temperature at the sensor to be well above the ambient air temperature below the sensor to the water surface. And that will definitely impact the accuracy of the level measurement. There's a question about, do we make samplers, portable samplers specifically with refrigeration systems? The answer to that is yes, that Teledyne ISCO does manufacture portable refrigerated samplers, and the 2 model options of those refrigerators are the Glacier, which is a composite single bottle only sampler, and the Avalanche, which can be configured for both single and multiple bottle, as well as a multitude of other capabilities that can come along with the Avalanche, such as rain gauge interface, SDI-12 interface, 700 series flow modules, telemetry, i.e. modems, to where we can remotely access. We can set up alarm conditions based upon the conditions that we so desire.
Steve, I see a question related to INI programs and whether or not they can be shorted when there's sufficient number of large storms encountered or documented within the data, say one in a 5-year, one in a 10-year, or a 25-year storm event is collected. That's an excellent question. And I would say that just based on my experience in dealing with municipalities anywhere from Chicago to Honolulu and all points in between, that the answer to that question really is a function of your regulatory body. If we're talking about a municipality that is in a state of consent decree, certainly you're going to have a different set of compliance regulations that you're dealing with than a community that is not. So my recommendation there would be to check with your local regulator and talk to them about what is sufficient for recording a large number of storms within each of those categories. But that's an excellent question, and your regulatory people should be able to help you with that.
And just to add on to that, the events themselves, for example, if you have a 100-year event and you only had that one event and you saw that you had an INI issue going on in that particular line, did we really discover that we have an INI problem in that particular pipe? The answer is we don't know. Because it may have rained to such an extent that we actually had intrusion coming in through the manhole lids. Who knows? We may have had backups because the capacity of the system was just overwhelmed due to the magnitude of the event. And probably we're not going to sit down and base all of our plans going forward based upon a 100-year event. But if we have a series of 1, 5, or 10-year, 25-year events that allow us to develop a trend that says, yes, we do have an INI event, regardless of whether the size of the event here, whether it's a standard, intermediary storm or 5 or 10 or 25-year storm event, all of them indicate that we've had a significant increase in the amount of flow being conveyed by this pipe. We learned what we're after. That's the key question that needs to be answered. Did we learn what we wanted to from this monitoring location? And if that answer is yes, then there's really no need to continue to monitor at that site, unless there's some other reasons why we would want to continue. We learned what we were after. There is a question here about will this presentation be available to attendees? To reiterate, yes, this will be recorded and will be made available on our website in a matter of days, so it can be viewed as necessary at your leisure.
I see a question in here related to wanting to activate a sampler remotely via modem, or does it have to be done locally? Dennis, you're our communications guru. Can you take that one, please?
Yeah, we do provide, or we have available, a modem, CDMA technology as well as GSM technology for the samplers. The samplers are controlled mainly by text messaging, so you can actually text it to get information back to see where its current condition is in. You can also tell it to take a sample. You can get alarms based upon pre-programmed conditions in the sampler, so you can be notified when a sample's taken, if there's an error in the field, when a sample's complete, so you can go out and get your samples. You can also log in with a computer using a terminal program and basically take over the front panel of the sampler. So if you need to change the program, initiate a sample before time, etc., you pretty much have the same control as if you were in front of it. Obviously, you still need to go out and get the bottles from time to time, but as far as controlling the front panel, you can do all that through a modem.
Okay. Thank you, Dennis.
Mm-hmm.
One other one, Steve, here about the standard pressure velocity AV sensor. How do you know if you have drift that affects the depth accuracy?
Well, that's actually not that difficult to do, with a couple of caveats. First of all, one of the things that one should do, again, at the site at the time of data collection, is review and take a look at that data. If you're going to have some sort of deviation issue going on with the sensor, you're not going to see a normal, good, steady, stable diurnal pattern. Some applications don't have a stable diurnal pattern, day in, day out. In other words, during the nighttime, your levels are a little more lower. During the day, they're a little more elevated. You may have a weekday versus weekend variance, but you're just looking for the consistency or repeatability in that trend. When you observe a deviation in that trend, that's a flag. It may be real, but it's a flag that says, hey, someone should take a look at this. And the means to do so is to go and take a measurement of the depth in the pipe, compare that with the depth indicated by the meter. Now, if there's a small deviation, 1/4 of an inch, you're probably better off just leaving it alone, because the error involved in taking a physical measurement can easily have 1/4 of an inch deviation. As the water rides up the ruler, was the ruler put at the bottom of the 6 o'clock position of the pipe? Was the ruler perfectly vertical, slanted one way or the other? The lighting may not be the best. So there can be errors induced in taking that physical measurement. So small deviations, you're better off just letting it ride, whereas you can get into what I call calibration overkill, where person A goes out there and because of how they measure it, they put an offset in and a bias 1/4 inch high. Person B gets out there and they see it and they bring it back down, so your level jumps up and down. And so you're inducing some inconsistencies into the data because we're constantly recalibrating and readjusting the level. Some level deviations are going to be quite easy to see. If there's a measurement of approximately 4.5 inches of water in the pipe and the meter indicates we have 13 inches, obviously that's not correct. So that's when a little more in-depth analysis of what may be going on, it would be necessary. Could we have a severely fouled sensor? Could we have a restricted or blocked reference line? Could we have a faulty sensor? The data is going to tell you a lot by looking at what you may have. If you have constant erratic level just going all over the place, which does happen, but it's somewhat rare, that could be a sign of a sensor issue. If we look at the data and we see that it's been consistent and has this trend from the day of installation, yet we have a 4-inch deviation between the physical measurement and the indicated measurement, the person that did the installation and initial calibration may have done something incorrectly. That's one of those things I was talking about in the analysis of the data. And as Dennis indicated during his specific section, we can correct that data if we understand what that deviation was from the get-go. We can, in the post-data processing, modify, edit, correct that level, and recalculate the flow data so we're back at where we should be. Mostly it's going to be observation, looking at the data, and the more experience that is developed in looking at these, the easier it becomes to make determinations of what direction we need to go to identify and what we can do to correct the problem. There is a question here about, I have some very large pipes and have had issues with sensors being torn out during large storm flow events. Well, there's two things. First of all, if you do have submerged sensor equipment, AV equipment, some applications are likely to require more beefy installation activity. You may need to stud mounting rings into pipe. If we have pipes that have flows 7, 8, 9, 10 feet per second, which there are a few of those out there, you would definitely want to take more additional measures to ensure and increase the secure nature of that sensor in the pipe. However, there is also another alternative. Teledyne ISCO does offer a non-contacting AV sensor option. We name that as our laser flow measurement device. The sensor itself will mount above the flow and therefore not be subjected to the conditions or the stresses of a hefty flow event, and therefore you would have the confidence that you're not going to go out there and find that the sensor is bobbing in the flow in the downstream pipe because it was, jarred loose during the significant event.
Okay, are there any other questions? Okay, if there are no additional questions, please check back with us in a few days. If you'd like a copy of this presentation, you go to isco.com. You should be able to find this in our recorded webinars area. Don't know if Sharon is still with us, if she'd like to close, make closing comments.
Yes.
Okay.
Yes, thank you for attending our Preparing for the Wet Weather Monitoring Season webinar today. And thank you to our presenters, Bob, Steve, and Dennis. It was recorded and a video will be made available. If you have any further questions regarding this webinar, please feel free to reach out to me through Zoom and I'll forward it on to the appropriate person. I can also provide certification of your attendance if desired. If you would like to receive a certificate, please email me this request and indicate which webinar you have attended. Thank you again for joining us. Stay healthy and have a great rest of your day.
I would also like to add my thanks for the attendance of everyone today. We appreciate you taking the time out of your day to listen. I hope the material provided today was beneficial. Some of it may have been rehashing or refreshing of some things that we already knew. Hopefully there were some new things that were also discovered. And again, to reiterate, as Sharon indicated, any questions that you have, please submit them and we will be happy to answer them for you.
Thanks, everybody.
Thank you again, everyone. Stay healthy and stay safe.